So in this topic, let's talk about the basics of memory circuit. Specifically, we're going to talk about the S-R latch. How does a computer retain memory? We've been talking about bits and bytes, ones and zeros, but how does the computer actually retain that information? It retains it one bit at a time using an S-R latch. All right, so let's take a look at this. I'm going to put a cheat sheet down here in the bottom right-hand corner. This is the NOR gate cheat sheet, just in case you need a little bit of help as we're going through this circuit. So here's the circuit. Now, what I want you to see is that there are two NOR gates, one here and one here. We have an S, which is the set. We have an R, which is the reset. And we have these switches. Now, these switches, I've just put them in because we're used to seeing them, and they help us to see state. However, these switches are actually outputs coming from other gate circuits. So if you can picture that this is one gate circuit, right? This right here. If you can picture that there are other of these and they're upstream, that would replace these out. But for now, I don't want to make this too complex for you, so we'll just stick with our little toggle switches that we're used to working with. Let's walk through how the wiring is done here. So I have a set that's brought into the NOR gate. Then from the output, notice that the output comes back up here to the other NOR gate. So it's an input to the other NOR gate that's on the reset side. So I have the reset comes in, and it's also wired to the other side. Now this is called a flip-flop. On the S side, we have Q bar, and then the opposite state of that is Q. This is actually where the memory is being stored. Now let's walk through what happens. So if I have power coming in on the set side, I get a 1 here. The reset is off. So this is off, this is off. What's going to happen? Off, off, gives me a 1 out of the NOR gate, doesn't it? So I have no power coming in. The inverse there, it's going to give me a 1. So then I get a 1 here on this side, which gives me power on both of my inputs into this NOR gate. And what do I get? I get a 0. See? So now I have a 0. I come up and I have a 0 here. So I have 0, 0, and a 1. That 1 just stored 1 bit, and the value is 1. I left the light here so that you're able to see it and visualize it in your mind as to what's happening. Through this circuit, we just set 1 bit of memory, and we set the value to 1. Now let's reset it. All we have to do is flip it around. So now the reset line goes high. And notice that Q now is off. Q bar is on. Set is off. There's that cheat sheet again, just in case you need it. And again, I just wanted to make a note that these switches are just for visualization. So we just stored 1 bit. And what did we store this time? We stored a 0. So an S-R latch is 1 bit. It's 1 bit of memory. Let's do takeaways. Ready? S-R latch, it's a flip-flop circuit. It uses 2 NOR gates. It's storing 1 bit of memory. When the set is true, it stores a 1. When reset is true, it stores a 0. You just learned how memory works.